Hello, welcome back. So today we are going to look at step-by-step instructions for building a decision tree from scratch. And this is going to be more of a theoretical framework. We're gearing up for implementing this in Python. We might tweak a thing or two while coding, but this really is going to lay the foundation of how we build decision tree from scratch in Python. So before the coding video, please do go through this video to understand the intuition, and we're going to walk through an example too. That way it's crystal clear when we jump into coding. So step one is just collecting and organizing the data. For the sake of this video, we're going to go back to our favorite example of fruits in the basket. So we're going to take our favorite apples and then our oranges. And for fungi, this time I'm also going to throw in bananas. Okay. So this is what our data set looks like. So how do we collect and organize the data? Let's decide what our features or inputs are going to be. So features and inputs are basically the characteristics that describe each item, right? And for us, those could be things like maybe color, or is the fruit round, or does it have like a thick peel? I'm just going to say has peel. And what is the label, our output? It's just type of fruit, right? That's what we're trying to predict at the end of the day. So it's just type of fruit. So when we are organizing the data, then our data set is going to look something like this. So type of fruit, and then color, round, has peel, right? That is basically what it is going to look like. And then let's go in and add some data. So let's say have an apple and it's red, it is round, but it does not have a thick peel, so I'm going to say no. And then let's say orange, it is orange in color, is round, but yeah, it does have a peel, there's no but. Okay. Banana, yellow, no, and then yes, it does have a peel. And each row here is just a fruit, right? So that means we can have multiple instances of apple. And for fungi, let's say this apple is green. Okay, so green, and then round, yes, and has a peel, yes. And then I'm going to throw in one more orange, just orange, yes, yes. And then banana, our yellow, no, yes. So we've essentially organized our data. So features are just color, round, and has peel. And then label is the type of fruit, being apple, orange, or banana. So let's move into step two. What color did I choose? Okay, step two. Step two is where you find the best question to split the data. So why do we need this? A decision tree classifies data by asking a series of yes or no questions, right? So the goal is really just to ask questions that divide the data set into groups that are as pure as possible. So how? We can try with different yes no questions. What could some good yes no questions be for our case? It's kind of easy for us. We took a really simple data set. So maybe like, is the fruit round? Does it have a peel? And then maybe like, is it orange in color? Why not, right? So that could be another question we ask. And then now to choose the best question, we measure how much each question reduces impurity. So what's impurity? This sort of ties back to our last video about entropy. If you're comfortable with the concept, feel free to not watch the previous video. But if you aren't, I highly recommend it because it's going to make it clearer, and it'll help you understand what we're trying to do here. So why are we doing this? So once we find the best question, we use it to split the data set into two smaller groups, like yes group, where the fruit matches the question, and then the no group, where the fruit doesn't match, right? So we do need like a mathematical way to measure how much impurity is reduced when we split the data set. Otherwise, if there is no mathematical way, how are we going to implement our algorithm? So this mathematical concept, let me write this before I move on the formula. So based on the best question. So what does our formula for entropy look like? We've already done this. So it's just going to be I equals to 1 C pi log 2 pi, right? Where your HS is just entropy of the set. Your C is the number of unique labels like apple, orange, banana, and then your PI is just the probability of class I in the set. That's PI as well, and you're just taking log 2 of the PI here. And we know that entropy equals to 0 means that the group is pure. Pure means maybe in that group it's all the same fruit, and then entropy 1 is completely entropy 1 is a completely mixed group, right? Like it could be 2 bananas and 2 oranges. That's a completely mixed group because there are 2 of each, and then total is 4. Okay, so let's walk through actual example so that it's clearer. So suppose we start, what do we have here? So we have like 2 apples and then 2 oranges and 2 bananas, right? So so it could be like fruit and then count apple, orange, banana, and I have 2 of each. So the probability of each fruit, my P apple is going to be equal to P orange. This is not always true, but in our case it's true because there's 2 of each banana. So that's just 2 by 6. Or 1 by 3 or 0.333, right? So that's the probability of each fruit. So what does our entropy look like before split? So H before split is going to look like P apple log 2 P apple, right? And then plus, everything's in bracket, P orange times log 2 P orange, right? And then plus P banana log 2 P banana. I'm closing the bracket, so everything has this negative sign multiplied by negative. So if I do the math correctly and add the formula, so P apple is 0.333 log 2 0.333. I'm going to times 3 because all of them are going to have same value just for this data set. Not always true here because of how our data looks. So if I do that, then that should be around, if my calculation is correct. So that's our entropy before split. Now what does entropy after split look like? Suppose for splitting we're asking the question, let me see, is it round? We're asking the question, right? So when we ask is it round, then our yes group looks like apple, orange. Now there are 2 and 2, right? Because only apple and orange are round. Now what does the no group look like? No group is our banana, right? It's just banana, nothing else is there. So no group. I am so sorry. My handwriting is really bad. So that's our no group where it's just banana. So our H or H, however you say it, depending on what part of the world you're in. So that would just be P apple log 2 P apple, and then P orange log 2 P orange, right? And that means 2 by 4 log 2 2 by 4 plus 2 by 4 log 2 2 by 4. I know this should be 1 because it's a perfectly mixed group, but feel free to verify it through calculation. And then for the no group, our H no is just going to be 0, right? So that's how you calculate entropy before and after the split. Now for step 4, it will be calculate weighted entropy and information gain. Now information gain, we've talked on the previous video. I'm gonna recap what we discussed in the last video. Feel free to watch the last video if you wanna go deeper into it, but I'm gonna briefly mention what it is here. So why we're calculating weighted entropy and looking at the information gain. So even after a split, some parts of the data set may still be impure, right? We've looked at this, it's still impure. So we calculate weighted entropy to see how much impurity remains after the splitting is done. Okay, so the formula for weighted entropy is, let me write this. So weighted entropy is a concept we're introducing. So this is your weighted entropy, and that's going to be n left by n h left plus n right by n h right, where n left and n right are just the number of samples in each group, and your h left and h right are the entropies of those group, right? Like how we calculated the yes-no entropies. And then n is just the total number of samples. Since larger groups contribute more to the overall impurity, weighted entropy ensures that we don't ignore the group size essentially. So our weighted entropy could look like 4 by 6, 1, and then that was 0, right? So that should be around 0.667. So that is what our weighted entropy would look like. So what does weighted entropy tell us? Recapping, weighted entropy helps us to evaluate how good a particular split is when dividing data into groups based on yes or no questions. So why do we calculate weighted entropy? If we want to choose the best question that makes the data as pure as possible, then we go through this exercise. So if we split the data set into 2 groups, each group will have its own entropy, and instead of looking at just one group, we calculate the weighted, sort of the average of their entropies based on their sizes. The resulting weighted entropies tells us how impure the data set remains after the split, and the lower the weighted entropy, the better the question was at making the groups purer. Okay, I hope that makes sense. Again, if weighted entropy is low, the split created purer groups. Good question. If weighted entropy is high, split didn't help much, and we should try another question. Okay, so that's why weighted entropy is important. And then exactly in terms of like mathematically how it helps us to decide or choose the best question is through information gain. Again, from last video, information gain is just, I'm going to write the formula. IZ is H before split minus your H after split. Your H split is weighted, okay? This one's weighted. So when we split the data set into 2 groups, each group have its own entropy like we saw. However, sizes of groups are usually not equal, so we need to account for the difference. So instead of the simple average where we're taking the weighted sum of entropies that we discussed earlier, and then we calculate the information gain through this formula, very simple formula. So high information gain basically means the question made the data much purer. Lower information gain, the question didn't help much. So this is how we actually take entropy and calculate information gain. Okay, and step 5 then is just repeat for each group. So if a group still contains multiple fruits, we repeat steps 2 and 4, 2 to 4 inside that group. And if a group contains only one type of fruit, then we can stop splitting at that point. So if H is 0, stop splitting because it's already pure. So this means every group contains only one type of fruit at the end. Okay. And so basically step 6 is just to stop splitting when all groups are pure. So at the end, what would it look like for us? So is it round? Then we have 2 branches, yes or no. As soon as we say no, we have our pure class for bananas. And then when we say yes, we still had oranges and apples. So we say, is it orange in color? We repeated this step, right? And then here, yes, no. And when we said yes, then at the end we only had only had the type of fruit orange remaining. And then here we had apple remaining. Okay, and I specifically chose this question because remember we did take that green apple. So let's walk through the green apple. Is it round? Yes. Is it orange in color? No. So it's still classifying the green apple correctly, right? But at the end of the day, it's just an apple. So I'm gonna put them in the same class and consider it pure because we are looking at type of fruit, right? Type of fruit, both are apple at the end of the day. The final step then is just really to step 7 is just really to make predictions. So now that we've built the tree, we can classify new fruits by following the tree. So we just walk through this like we did for the green apple, and then we decide or we predict what that fruit could be. So prediction means that fruit is no longer from this basket. I am bringing a fruit from a different basket, and then I'm trying to predict, right? that's so that's the last step, making prediction. So this is just high level overview of how decision trees work, and when we code it, we're going to tweak a thing or two, but this is really going to be the backbone of the code. So I hope you have a good understanding on this. If not, feel free to ask questions down in the comment. Also, please let me know, like I do want feedback. Are these videos good? Are they helping? If not, let me know what I can do better so that we have good learning overall. The goal really is to have a healthier learning environment, so please feel free to let me know. But yeah, I will see you in the next video.